Lesson 8.1 Polar Coordinates. So before we get into the exercises, I'll just explain how to convert from polar to rectangular and the other way around. So first of all, this is a polar coordinate and this is your typical XY rectangular coordinate. So if you want to go from polar coordinate to rectangular coordinate, you have two formulas you have to use. So first is the formula for x, which is r cosine theta. Then the formula for y, which is r sine theta. So let's say we have like a number here which is 8, and here will be like 3 pi over 2. So the way you'll get x would be x is equal to 8 cosine 3 pi over 2. Then you'll find the answer on your calculator, but make sure your calculator is in radian. Then y is equal to 8 sine 3 pi over 2. And again, make sure your calculator is in radian. So your 0.8 and 3 pi over 2 becomes 0 and -8. And you can graph this normally on the rectangular coordinate system. Now converting from the xy to the r theta coordinate is a bit more complicated, but it's still relatively easy. So from xy to r and theta. So first of all, you'll have to find r, and r is pretty easy to find, so you'll just do r squared is equal to x squared plus y squared. And then let's say this is 3 and 4. It will be r equal to plus and minus, because we added the radical ourselves, so it will always be plus and minus. Plus and minus 3 squared, or radical 3 squared plus 4 squared, which will equal to plus and minus 5. On to finding theta. So the first step of finding theta is determining the quadrant of the xy point. So since the xy point are like the coordinates are both positive, so the x is positive and the y is positive, then we are in quadrant 1. So this is quadrant 1, this is 2, this is 3, this is 4. In 1 both are positive, x and y are both positive. In 2 x is negative and y is positive. In 3 they're both negative. And in 4 x is positive and y is negative. Okay, so since both are positive, it's quadrant 1. So then to get theta we do tan inverse of y over x. This is an equal sign. So again, theta is equal to tan inverse of y over x, which is here 4 over 3. So tan inverse of 4 over 3 is 0.927. And then you find theta prime. So here theta prime, you just do a shift tan of 0.927. You'll get the same answer again. So 0.927. So the theta is already theta prime. So after that, since it's in quadrant 1, we do the theta prime formula for quadrant 1, which is theta of quadrant 1 is equal to theta prime. Okay, I'll just write the formulas for theta prime for each quadrant. So for quadrant 1, the theta of quadrant 1 just equals theta prime. For quadrant 2, it's equal to 180 minus theta prime, or if it's in radian, it's pi minus theta prime. For quadrant 3, it's equal to 180 plus theta prime, or pi plus theta prime. For quadrant 4, it's equal to 360 minus theta prime, or 2 pi minus theta prime. Okay, back to our question again. So now we need to write the coordinates for the polar coordinates for the rectangular ones we just converted. So since we have two R values, so the first R value is just 5, and that will just equal to our theta prime in quadrant 1, which is 0.927. So we can write it this way. This way is completely fine. Okay, but let's say for example they ask you for the other R. So let's say they'll ask you give the polar coordinate when R is negative. So it will be -5, but now we need to change our theta. So if we want to get theta when we change the R value or change it or make it negative rather, you have to add or remove pi depending on the range. So in most questions, or usually it will probably be every question in the test, your range will be from 0 until 2 pi. So 2 pi is not included. So let's convert 2 pi into decimal value. So 2 pi is 6.28. So you have from 0 to 6.28, your theta value has to be in this range. So again, let's go back to our question. So since we switched the value of r or made it negative, we have to add or remove 2 pi. Not 2 pi, we have to add or remove pi. So let's say we remove pi. So 0.927 minus pi, it will be negative 18.8. But we cannot have negatives in our theta value because our range is from 0 till 6.28. So we have to add pi since removing pi won't work. So let's add pi. So 0.927 plus pi is equal to 4.068, and that's completely in our range and it's completely fine. Okay, let's start with the first question they can give you. They'll ask you, for example, to plot the point. I'll take this from the book. 4 and pi over 6 in a graph. Now this is a polar coordinate. So the first thing you do is draw a coordinate plane. So this is our coordinate plane. And then draw like a few circles or 4 circles here since we need 4 circles. They won't ask you to plot or graph anything on the test. They'll just ask you if does this point match this graph or not. Okay, and after that we need to find which direction this theta exists in. So I'll convert it to degree because it's easier to find out that way. So if you want to convert this angle here to degree, we do pi over 6 times 180 over pi. So this and this cross out, then it's 180 over 6, which is 30. And we know that 30 is in the first quadrant, or angle 30. So it will be at like here, like close to here. Okay, now that we know the direction for it, we can count like 4 circles. So since this is 4, we just count 4 here. So 1, 2, 3, 4, and then we draw like our line, and this is the point. This is the point that they're asking for here. Okay, let's say for example they ask you for -4 and pi over 6. You have to draw it the opposite direction. So again, you'll draw this point here, but then you'll draw on the opposite side of it a dotted line, which is 4 circles long, I guess. And then you'll just draw the point here. Okay, let's do question 22 in the book. So question 22, this question will help us like prepare for the other questions, the converting polar to rectangular questions. So here they're just asking us to find two other similar points to the point they give. So the point they have given is -2 and 4 pi over 3. So first we'll find two other points, or yeah, we'll find two other points with -2, and then we'll find 2 points with with positive 3. So to convert or to find another representation of a negative 2 point, you just add or remove 2 pi. So here you just plus 2 pi or minus 2 pi. So here we're assuming we don't have any restrictions. So there's no from 0 till 6.28. This doesn't exist here. So plus 2 pi, it will be 10 over 3 pi, and then minus 2 pi, it will be negative 2 over 3 pi. Okay, so that's the 2 points for the negative r. Then for the positive r, we have to add or remove pi. So plus pi, minus pi. So minus pi is pi over 3, and then plus pi is 7 pi over 3, or 7 over 3 pi. So all these points, all these 5 points are the same point, but they're just written in a different way. But they, in the graph, they will all mean the same thing, or they will all look the same. Our next question is number 24 in the book. So here they're asking us to convert the polar point 6 and 2 pi over 3 into x and y coordinates. So here we're going to use these two formulas, these ones here. So x is equal to r cosine theta. This is r and this is theta. So here it will equal to 6 cosine 2 pi over 3, and here it will be y equal to r sine theta, which is equal to 6 sine 2 pi over 3. And then you do both on the calculator. You have 6, make sure your calculator is in radian. 6 cosine 2 pi over 3 gives you negative 3. And then sine gives you 3 radical 3. So the point is negative 3 and 3 radical 3. That's our answer. Okay, next let's do question 34 in the book. So here they're asking us to convert negative 7 radical 3 7 into polar coordinates. So here let's write, we're gonna use the, oh, it's not written here. We're gonna use r squared is equal to x squared plus y squared to get r first. So first we're gonna get r and then we'll get theta. So for r, it will be r is equal to radical negative 7 radical 3 squared plus 49. Then you do this on the calculator. Negative 7 radical 3 squared plus 49, which gives you r plus minus 14. It's always plus minus. Okay, so now we find theta. So the first step to finding theta is getting the quadrant of the coordinate or rectangular point. So here it's negative positive, and if we look here, negative positive is quadrant 2. So our point is in quadrant 2. Okay, so now we get theta. So theta is equal to tan inverse of y over x, then tan inverse of 7 over negative 7 radical 3. Tan of 7 negative 7 radical 3, which will give you negative pi over 6. Then we find theta prime. So shift tan of negative pi over 6 should give you pi over 6. And now we want it in quadrant 2. So we use the formula for quadrant 2. So theta of quadrant 2 is equal to pi minus theta prime. So here it will be pi minus pi over 6, which should give you 5 pi over 6. And now we write the point itself. So for the positive r, we're gonna write 14 and just 5 pi over 6. And then for the negative part, we're gonna have to add or remove pi, and depending on our range, which is 0 to 6.28, we're gonna decide which one we want to use. Negative 14, and then we add pi or remove pi. So first we'll add pi, so 5 pi over 6 plus pi gives you 5.75, and that is in our range, so it is the answer. But for example, let's say we removed pi instead of adding pi, we will get negative pi over 6, which is not in our range. So the answer is just 14 5 pi over 6 and negative 14 5.75. Okay, so for our last part of the lesson, we will just cover a few questions that might come in the test, and they're very unique. They're unlike the other questions. So we'll start with question 46. So in question 46, they're asking us to write a similar equation using polar coordinate. So they're basically asking us to convert the rectangular coordinate or the rectangular equation into a polar equation. So here again, we're gonna use these formulas to convert them. So x is r cosine theta, so 3 and r cosine theta plus 2 times r sine theta equal to 6. So we distribute, so 3 r cosine theta and 2 r sine theta is equal to 6. And then we can remove r from both sides here. So r is 3 cosine theta plus 2 sine theta equal to 6. Here we're basically isolating r. Then r is equal to 6. 3 cosine theta plus 2 sine theta. And that's our answer. So next question is 48. It's easier than the last one. It's just y equal to, and they're asking us for the same thing again. So y, we can replace it with r sine theta is equal to 2, and we're isolating r, so it will be r is equal to 2 over sine theta, or they can write it as r is equal to 2 cosecant theta. It depends on which one you get on the answer choices. The next one is question 50. So 2x squared plus 2y squared equal 50. We divide both sides by 2, so x squared plus y squared equal 25. And since we know that r squared is equal to x squared plus y squared, we can just substitute this by r. So it will be r squared is equal to 25. So the answer will be r is equal to plus minus 5. Next question is question 58. Here they're asking us for the opposite. So we have r equals 7 and we want it in rectangular form. So here we already know that r squared is equal to x squared plus y squared. So r would equal to radical x squared plus y squared. So we can substitute this by r. So radical x squared plus y squared is equal to 7. Square both sides. So x squared plus y squared is equal to 49. And that's our answer. Next question is question 60. So 60, r is equal to r is equal to secant theta. We can write this as r is equal to 1 over cosine theta, and then cross both sides. So this will be multiplied by this, and 1 times 1. So r cosine theta is equal to 1, and r cosine theta is x, so x is equal to 1. Next question is question 62. So question 62 is asking for the same thing. So we have r is equal to negative 2 sine theta. So we multiply both sides by r. So it will become r squared is equal to negative 2 r sine theta. So this will be x squared plus y squared. Then r sine theta will be x, or y, sorry, negative 2y. And we can just leave it this way or make it x squared plus y squared minus 2y equals 0. Depends on the answer choice, yeah. On to our last question, 64. So here we have theta is equal to pi over 6. We add tan to both sides. So tan theta is equal to pi over 6, or tan pi over 6. So tan pi over 6. We can do this on a calculator. So it will become tan of theta is equal to radical 3 over 3. And tan theta equals to y over x, because when we're converting from polar to rectangular, we do theta is equal to tan inverse of y over x. You can rewrite this as tan theta equal to y over x. So we just substitute tan theta for y over x. So y over x is equal to radical 3 over 3. And then depending on the answer choice, let's say it's y equal to radical 3 over 3x. This will probably be the answer choice.